Hello everyone. So this is the project provided by Exposys Data Labs where we have to create a ML model that can predict the profit value of 50 startup companies if their R&D spend, marketing cost, etc. are given. And I'm running this code in Visual Code Studio. First of all, we'll start by importing the required libraries. As you can see, I've imported the Pandas, Seaborn, Matplotlib, um, and Panda for analyzing data, Seaborn for visualization, Matplotlib for graphical representation and visualization. And next up is we have to import the data set. This is the code for it, and this is the path where I have stored my data set. So let's run the code. So this is our data. Let's check the data first. Next we'll analyze the data. First of all, we'll check if there is any missing value or not in the given data set. So as you can see that there is no missing values, but from the data we can see that there is few value which is 0, which actually reduces the accuracy of the model. Next up we'll check the schema of the data set. Here we can see the ranges, number of entries and types of data. Now we'll come to the visualization part. First of all, we'll find the correlation between column using correlation function. We can see that all three columns have direct relationship with the profit, which is our target variable. Next up, we'll draw correlation matrix using Seaborn library. From this heat map, we can see the direct correlation with the profit, which is our target variable. Now we have is outlier detection in the target variable, which is our profit. We can clearly see that there is outlier in the profit, which is the target variable. Next up, we will draw histogram on profit. From this histogram plot, we can see the average, that is 100,000 is the most frequent, which is the average. Next up, we will draw the pair plot for understanding the relationship between the variables in the data set. So let's check it out. So this is it. As you can see from the pair plot, we can see that R&D are directly proportional to investments, and marketing is also directly proportional to profit, whereas there is no relationship between second column and the profit. So this ends our visualization part. Next is our model development. First of all, we'll start by splitting the dataset into dependent and independent variable. So as you can see, I have used the ilog function, which is to select the specific rows and columns. So from here you can see it is the data is splitted into dependent and independent variable, that is x and y. Next up, we'll import label encoder from sklearn dot preprocessing. So it's been imported. Next up, we'll encode label with values 0 and n class minus 1. Here it is. Now we have to split the data into train and test set. We'll be using the sklearn function to first of all we'll import sklearn.model selection from first of all we'll be importing train test split from sklearn.model. So for let's train our this model, actually splitting the data. So this is it. Now we'll use another function to actually check if linear regression function to check if the model is trained or not. Actually it's been written model has been trained successfully. We can also write model have not been trained successfully, so it will print the same thing. So if you will write model have not been trained successfully, then it will show model have not been trained successfully. So it's up to you. So we'll be testing the model using predict function. So this is it. So as you can see, our model has been already created. Now we'll be testing the scores, model scores. So as you can see, the testing the model score for testing data and training data is there is not much of a difference in it. So now we'll be actually comparing the predicted values with the actual values. So this is it. Our result is so we have already tested our model. Now we will evaluate and check its accuracies. First of all, we have to import R2 square, which is squared score. R2 square, which is used to find the variance of the target and feature data. Let's check it out. So R2 score of the model is this. Next up, it is MSE, which is mean square error, which measures the amount of error in the statistical model. So if the MSE is 0, then the model has no error, which is quite impossible. So let's check it out. So this is the mean square error. Now we have to simply check the root of the mean square error. So this is the root of the mean square error. Next up is MAE, which is mean absolute error. It is used to find the difference between the actual and predicted values. So we have again used sklearn matrix to import mean absolute error. Now let's check it out. So this is our mean absolute error. So we can conclude with this that the mean the mean absolute error is this. So therefore our predicted values can be more or less than uh, this mean absolute error compared to the actual values. So that's it. Thank you.